Hi and welcome to Geeks for Geeks. Today we would be discussing the problem complete binary tree. In this question, you are given a binary tree and you need to check whether it's a complete binary tree or not. Okay. So before moving forward into this problem, let us understand the prerequisite. What are the prerequisites? The first is, what is a binary tree? What are we given? What is the meaning of that? Then what we need to check. Okay, so let's first understand. So binary tree is a tree which can have at most two children. As there are at most only two children, that is 0, 1 or 2. So either it can be a leaf node, or it can have like this, or it can have like this. But having this kind of structure is not a part of binary tree. So as there are only two children, so it is referred to as the left and the right. So this, the left hand side, the node on the left hand side is referred to as the left child. On the right hand side, it is referred to as the right child. Now, if this is the definition of binary tree, then what is complete binary tree? So complete binary tree is a binary tree where all the levels are filled except the lowest. So every level should be filled. What do you mean by filled? That every level should have the complete two left as well as the right subchild, except the lowest one, because in the lowest one it can be unfilled. Okay, but there is one thing to note here. The thing to note here is that the lowest one, suppose it is filled, it is getting filled, but it should be filled from the left hand side. Either the whole of it should be incomplete or the right hand side should be incomplete. But if there is a part on the right hand side but on the left hand side it is incomplete, then it is not a complete binary tree. What do I mean? I would make you understand. I meant that, okay, this in this scenario, this is a complete binary. So what do I meant by this? I meant this, that suppose we have a complete binary tree. In this, all the levels are fulfilled. Each node has the left and right. But suppose we have this kind of structure. If we have this kind of structure, then also it is a complete binary tree. Why? Because the first level is fulfilled and the last level is incomplete, but it has been filled from the left hand side. But if we have a structure like this, then this is not a complete binary tree. Why? Because the left hand side, last level left hand side is incomplete, but right hand side is complete. So let us take some more examples which would make you very much clear. Suppose we have this kind of structure. If we have this kind of structure, then it is an incomplete binary tree. Why? Because if the nodes were filled from this part, that is like this, then it was complete because it is filled from left to right. Okay, but if it is filled from right to left, then it is not a complete binary tree. Okay, and there is some incomplete section. So now we know that a complete binary tree is a tree where all the levels are fulfilled except the lowest, and lowest level is filled from the left. Okay, understood? So now let us move back. So we can say that in the given sample, the first one is a complete binary tree and the next one is an incomplete binary tree. So the answer to this would be false and the answer to this would be true itself. Okay, so we are done till this point. Let us move forward. Okay, so now if you analyze the sample test case that is given, so what we can do is, see, this is complete. Why? Because it has left as well as right. This is also complete. Why? Because this is having a null. So you can see that after having here null, if I am encountering, okay, if I prioritize that, suppose I would first go to left, what I would do is from the root. Suppose every traversal technique starts from the root. So from the root, okay, from the root, I would first go to the left hand side and then I would go to the right hand side. I can say that. But what I can say more is that if left hand side is incomplete, if left hand side is incomplete but right hand side is complete, then we can say that this is not a binary tree, not a complete binary tree. What I meant to say is, I would be first going to the left hand side, then I would be moving to the right hand side, and I would be doing a level order traversal. Why level order traversal? Because see, first I would visit the first level, okay, then I would visit the second level, and then I would start from the left hand side. Remember it, I would start from the left hand side. So again I would do a level order traversal from the left hand side, and if I have seen a problem here, then again if I am seeing a problem, that means that this side there is an incomplete but this side there is complete. If this is happening, then this is not a complete binary tree. Okay, so what we would be doing is, we would be doing first a level order traversal. Okay, and in each level we go from left to right. Okay, we do a level order traversal, we go from left to right. Now what I would do is, if I encounter a incomplete node, what is an incomplete node? A node which does not has both the childs. So if I encounter a incomplete node, I would mark it. Okay, suppose I mark OK, because we would be using OK only, OK variable. Suppose I mark OK as true. Initially it would be false, but if found incomplete, so if I found incomplete, so if I find error, what do I mean by error? An incomplete one. If I find an error, I would mark it. But if after that error I am finding a node in the level order which is being complete, then that is not a complete one. So I can say that if I found the error and even after that a non-error, even after that I get a good node, then false. That is not a complete binary tree. Now let us see what is this all about. So what I said is, see this very carefully, how this is working. Let us do for a complete binary tree. Okay, let us do for a complete binary tree where from the left hand side it is done, but on the right hand side it is not done. This is a complete binary tree. What we would do is, we would do a level order traversal on the very first level. We did, and this is complete. We did a level order traversal, and this is also complete because each one is having. Then we found out, then we go from here. It is not a null node, it is not a null node, it is not a null node. But then we found a null point here. So we found a null point here, and after that null point, we didn't got a node which is good enough. Okay, that is why we never encountered this false condition. So we can say that yes, this is a complete binary tree. Now let us see for an incomplete binary tree. So it would be kind of like this. It would be like this. This is an incomplete binary tree because from the left hand side it is incomplete. So now we would do a level order traversal. The first node, there is no null. There is no null. And in the last node, we encountered this position as null. And after null, we are encountering a node which is not null. So first I got an error, and after that error, I am getting a good node. So this would give me the condition in this position only that yes, this tree is an incomplete binary tree, or your tree is not complete. Okay. So to do a level order traversal, now the question arises how we would do the level order traversal. Whenever we talk about level order traversal, we have the two most famous, that is depth first search or breadth first search. Okay, depth first. So what we would do is, we would simply do a BFS. We would simply use a BFS, breadth first, which would do level order. Okay, or you can simply do the recursive one also, but we would move forward with the iterative one. Okay. So now we would go to each level from left to right. So we would prioritize our going on the left hand side, then going on the right hand side. Okay. So now let us move to the implementation. So here we have the root given. So we would simply say that if root is equals to null, So if root equals to the null, then we would simply return a value true. Okay, then we would initialize a queue. Okay, to do a BFS we initialize a queue. So please read about queue if you're not familiar with. So please read about queue as well as breadth first search if you're not familiar with that. So what we would do is we would do a node and then queue itself, and then we would push the root. Okay, like we do. Okay, we push the first source node in the graph like we do. Okay, and then we would say that while q dot empty equals to the false value, while q is not empty. Okay, and we would initialize a boolean okay as false. That till now we have not received the error. Okay, this means that didn't no error till now. Okay, this is just telling us that there is no error as of now. Then we would take the very first node. Okay, that is temporary, and we would store q dot front, and then we would remove it from the queue. Okay, just like we do the normal queue part. Okay, then what we would do is, if the current node of the left hand side, first we would visit the left hand side first. I told you we would move from left to right. So tp dot left, if tp dot left, that there is a node present, if there is the node present. So if there is a node present, we would first check earlier was there any error or not. So if okay equals to true value, if okay is true, that means already there is an error. This means that this condition is being like this condition. Yes, see, like there is already an error. Now we are receiving a good node. So if we are receiving a good node and there was already an error, that means we would return false from this point. Okay, we would return false from this point. Then if that is not the scenario, that earlier there was no error, then what we would do is we would keep doing what we were doing. Q dot push tp dash left. Okay, now we would say that this means that node is valid. So node is valid. Okay, and if condition is not running, that means node is null. So if node is null, that means we encountered an error. So we would mark the error as 1. Okay, so now we would go after done with the left hand side, we would go to the right hand side. So if tp dash, so we would just do the corresponding things. So instead of just, before writing, let me show you in which places I would change. So I would simply change the tp left to right. This is what I would do, and I would push the next one. Other than that, I would change nothing. So what I can do is I can simply copy that also. So now we have just checked about the left hand side. Left hand side is checked, so we would move to the right hand side. And if it is true already, we would not do it. tp dash right, and then the node is null, so we would return 0. If the iteration is complete and we received no errors as of now, okay, because the last one is allowed to 1, so we would return a true value. Now let us see how many mistakes I am making. Okay, seems like we are getting correct out of the sample test case. Now let us submit this and see. And yes, we got an EC. Now before talking about the space and the time complexity, let us just see that if we are moving from the right hand side then to left hand side, see, this is not gonna work. First we are checking the right hand side, so opposite condition. So if this definition is not valid, then we would get a wrong answer. See, we get a wrong answer, but if we do the previous one, we would get the correct answer. Fair enough. So now let's talk about the time complexity. Talking about the time complexity, we are visiting each node exactly once. So that is why the time complexity is big O of n, where n is the number of nodes. Talking about the space complexity, we are using a queue to store the nodes. So in the worst scenario, all the nodes would be stored. So this is also big O of n. So time and the space complexity is this. Now, that's it for today. So if you were till the very end of this video and you think that this work should be justified, feel free to comment this video and like this video to increase the reach of this video. Thanks a lot.